with the overlay layer here, which is, we've been talking basically about having a globally available registry of overlays so that any system or service that is in the system can both make sure that its overlay needs are being met and also make sure that things get onto the correct overlay. And one way of achieving this, not the only way by any means, but one way of achieving this is using the LISP mapping service. So they're sort of, LISP has the sealing wax and dessert topping sort of thing going on where there is a LISP encap for tunneling, but there is also the mapping service that maps to things. The LISP mapping service can allow you to take fairly arbitrary keys, destination IPs, source IP and destination IP combinations, NSH headers, all kinds of things, and map those to a particular overlay topology. So that basically you can find out if I've got a chain that something's supposed to be going through for service function chaining or for traffic engineering, and I have a destination IP or I have an NSH header, I can find out what that chain is in a consistent way, and traffic can be moved along that chain. So just wanted to talk a little bit about that as a way to solve this problem and some of the things that you would want to do in order to achieve that. So we're fortunate in that we actually have a LISP mapping service in OpenDaylight. So we've already got something that does high performance registries of, basically a high performance registry for keys to overlay topologies. What we don't have right now that we would need to do going forward is actually have the ingress and egress tunneling router functionality to handle the data path piece of moving those flows along. Often, when you're talking about this in LISP, you'll talk about an ingress tunneling router, which is the router at which, the point at which something gets encapped onto a tunnel, or the egress tunneling router, the point at which it gets de-encapped at the other end of the tunnel. And often you'll simply call that combination an xTR because they're often the same thing. And so what we would be looking at is doing xTR functionality in order to be able to program things like OVS, in order to be able to do other sorts of things of that nature, so that you can actually do this dynamic overlay tunnel piece. Now, I actually know we have a lot of folks in the room who are actually much deeper in LISP than I am. Who here is actually not terribly expert in LISP? Okay, awesome. So, I don't know if you, I don't want to put any of the LISP folks in the room on the spot. Are there any of you who would like to actually say something more intelligent than I am about how the LISP mapping function works? Not necessarily down to the bits and the bytes. It's really, so in a lot of sense, it's actually conceptually, putting aside like the technical details that you don't necessarily have to get your head into very deeply, it's really simple. I have a key. It's very much like what was shown up here in the diagram. I have a key. That could be a MAC address. It could be a destination MAC, a destination IP, an NSH header, a combination of source and destination IP, et cetera. I have this key, and I need to do a lookup to find out the overlay that I should be putting things on for this particular key. I do that lookup, and then the xTR can put me onto the appropriate overlay from the point I am in that overlay. And you may be wondering, sort of like, people tend to think about tunnels as simply point-to-point things. But it turns out when you're talking about service function chaining, when you're talking about traffic engineering, when you're talking about a lot of these other things, you actually do want an overlay topology, not just a next hop. I don't know how good an explanation. Does that make sense to the folks in the room who are just getting started with Lisp? And Daryl, you look cross. Am I getting this wrong?
I'm not cross. I just think, I think you're right that you're calling out that tone as a kind of a poor choice of words here, because what we're trying to do is a unidirectional dynamic encapsulation.
Mm-hmm.
And
give them in a mic.
So what we're trying to do is a unidirectional dynamic encapsulation, not necessarily a tunnel encap, because there's no implied symmetry, right? And there's no implied, single or multi predetermined destination. And I think that's the difference, is that tunneling is a word that works really well in the interface model because we all intuitively understand that because of the physical analogies that spring to mind. But I think unidirectional dynamic encapsulation is a more accurate term that kind of applies. It's much more like Ethernet than it is like, GRE.
Yeah, I mean, I think that's a subtle but important point.
So I think Colin had an interesting view of how we put the services, network services together, or VNFs together, and so on. And he was talking about the recursion stuff, and he was mentioning that any of these services or VNFs, in a way, can be an overlay of their own in an abstract way. So so in that way, the chain that you have, like, or the pipeline that you drew, which is the group-based policy sends something to SFC, sends something to maybe group-based policy back again. That's kind of the high-level logical handling of packet that we're doing between the services. And then, well, the SFC that we have today is kind of an one-layer thing. So it takes packets from one defined VNF to another. But if you want to kind of follow that that abstraction model, then the SFC may, I mean, that blob, we want to generalize this, right? So we want to say that SFC can be any blob. I mean, some other form of OpenDaylight service that we want to hand the packet to do something with. And then that one may end up being another kind of pipeline of its own, right? So that kind of captures this, and it has a good mapping to the overlays in that sense. So we can call this an overlay of ODL services instead of a pipeline, for instance.
That might be a possible way you could express it. Yes.
Right.
Yeah.
And so that gives us a good way of representing these, and then within each service, within each hop or step of this overlay, each one can define its own kind of overlay and how it wants to go through that. And that gives, I think, a good view of how we can use this mapping of a key to an overlay, and how it would map well to this model.
Yeah. So I mean, it does end up being. I mean, it's a useful way to think about it. Honestly, when you get to the end, there is something like a MAC address or an IP address or an NSH header that determines what overlay you should be put on. So there is a key to look up, and then the question is, what are the set of hops that you're going to be going through? And you'd like to be able to express the complete topology to the overlay system, because you don't want to have to go doing the hop-by-hop programming. That's the problem of the overlay system. So, are there questions, or do people have other thoughts in this direction, or other sort of subtleties of this they want to express, or sort of questions about doing xTRs or some of the challenges that might happen there? We get less chatty as the sessions go on. I think people are getting tired. Yeah, no, it is getting late. It is getting late. No, it supports a wide assortment of. Absolutely. So you can have whatever encaps you would like. You can have heterogeneous sets of encaps within a given topology. All that's doable.
So I think we have the distinction between, maybe LISP as a specific protocol with a specific encap, and then what we want to talk. I mean, what I think Ed is talking about here with it, which is the mapping system and the LISP architecture per se. And then maybe some parts of its control protocol and so on, but generalized so that it could offer some of those overlay services in general. So not that we make everybody else understand specifically Lisp, but we make that architecture general so that everybody else can use it.
Yeah.
So that's why the encapsulation format really doesn't matter. We can store capabilities of this node, can do VXLAN or GRE or NVGRE, or the three of them, and then select between them or something of that nature. So all of that goes along the line of generalizing the capabilities into an overlay service. So that is what I guess the goal is.
Yeah. So I mean, I think the idea would be, say you have a situation where you're doing, so you have something with an L3 context. So you know that there's a routable IP address, and that's the thing you get around with. And so you actually know where it is, and you know that you can be tunneled to with VXLAN. And so or VXLAN GP. And so you would basically go to the overlay system and say, for the key that is this destination IP, this is a one-hop topology that takes you to that tunnel IP with this encap. And then you're done, right? And then all you do is you punt off to the overlay layer. The overlay layer is sitting here having the registry entries coming in from all the other pieces of the pipeline, saying, okay, I'm going to hand this off. And so where this makes simpler some of the situations we found with GPB and SFC is GPB would put all of those entries into the overlay system. SFC would put in its more complicated topologies for service function chains. So you would get to the point where you go to hand off to SFC with the header. SFC would hand off to the overlay layer, which would look these up, stick it through the various hops of the SFC. When it gets to that last hop, basically now you're in a situation where it can ask the overlay layer, hey man, I now have this thing with a destination IP because it's come off the edge, and where do I send it? And it would go and it would find your entries from group-based policy that tell you where the other end is. Now, I know that there are some tricky bits with recirculation we should talk about there, but yeah, that's the basic idea. Yeah.
One of the things that maybe would be useful or interesting to think about at this point is what are the types of things that the overlay is responsible for understanding that you can take advantage of? And a couple of things that come to mind that are maybe not obvious, and one of them is reachability, because you don't have, you meaning the edge of this at the service layer or something, doesn't have to understand whether there's 4 paths to the destination or 3 paths, or there was 2 paths and now there's a third that got added, right? All of that reachability tracking is responsibility of the overlay. The second aspect that is tracked by the overlay that is interesting is the actual location. So if you have a mobility event where a VM moves from one part of the data center to another part of the data center, the overlay through this registration system implicitly has to know that move happened. But none of the pieces that are subscribing to that overlay in terms of reachability, saying I've got this destination IP, I want to send it someplace, need to be informed about that mobility event. And so you can contain the rate time state requirements of the control plane, in a way that is not being flood and learned or doesn't impact the scalability of the subscribers.
Yeah. Cool. So other thoughts that folks have, other questions? I know it's getting late, but in some ways it's a really simple concept. It's a really simple way to approach the problem. There are lots of tricky details, though, over the last decade that LISP has successfully worked out in terms of how you map these things, the kinds of things you map. Because one might assume, and I did some of this when I was starting to put together some of these models in OpenDaylight originally, away from the LISP concept, that like, okay, great, you do this simple case of a simple tunnel, but then you whack into things like SFC where you've got more complicated behavior, or you whack into cases that involve traffic engineering. You could imagine, for example, you could easily imagine traffic engineering cases leading to differentiated exit that you might want to apply by policy to traffic. And so you might wind up in situations where you have more complicated tunneling behaviors even from a policy point of view. Yes?
So how would I consume this?
Could we get a mic?
Should I just repeat?
Yeah, please.
Oh, so can you maybe walk me through how I'd consume this? Because you know how our pipeline currently works, so.
Vaguely. So the notion would be that the way you would go about consuming this is that when you find out about an endpoint placement somewhere, that you go ahead and now you know where it is, and you have some notion of what level of the network context it is. Maybe it's sitting in it may be an L2 context, it may be an L3 context, et cetera. And so you know the appropriate address for that. But let's just say IP for the sake of argument, right? So you know you have this IP address, it's placed there.
Well, so sorry, just to clarify then, because this is going to help me understand.
Please.
So there's the endpoint's IP address.
Yes.
In whatever namespace it is.
Correct.
So I still have to know the IP address of the destination node, the destination network element, correct?
Correct.
And that's the key that I'm looking up in Lisp.
That's the key that you
XTR.
would be both writing when you figure out where it is to Lisp, and then that the overlay layer would be looking up when it makes sure that it gets from A to B for you correctly.
Okay. And so, there's now a map of
Yep.
node IP
keys to
address, node IP address to where the endpoint actually lives, regardless of what namespace.
Yeah, where it is and what encap you use to get there.
Okay. So, and I already know this information because I'm the one who wrote it, right?
Right. Exactly.
So, given I already know that, and I already know the encap that I'm going to use to get there,
Yep.
and I'm relying on the underlay anyway, what am I getting from Lisp above and beyond would
So
kind
what
of
you're,
help
what you're
me?
getting is a place that you can advertise this information to other members of the pipeline, like SFC.
Ah.
So basically now when SFC gets to where it's going and it's trying to figure out how the hell to get back to you to do the final delivery, now it's sitting here, it actually has the ability to go look up within Lisp, that's where it goes, without you having to manually figure out case by case by case, and other member of the pipeline by other member of the pipeline, how you're going to pass that information on to them. Does that make sense?
Does that mean they wouldn't need them? Okay, unfortunately not, because in the case of SFC, I still need to pass. Well, what we do is we still have to pass the ultimate node destination in the context metadata, right? And so then it's the.
Well, that's what you're doing now.
So you're saying I wouldn't need to
What I'm saying is you wouldn't need to do that because it would, when it gets to the end of the service function chain and it gets handed off to the overlay layer, that overlay layer has your registration of where it's supposed to go for that destination, and it can take care of that for you.
The destination isn't the VM's IP address. The destination is the network element's IP address, and that's what's kept in the context metadata.
No. So basically, right now in the context metadata, you're putting basically the IP of the tunnel destination.
Yeah, the network element.
Right. You're putting the IP tunnel dest in there.
Yeah.
And you are presuming an encap, right? A VXLAN GP, a VXLAN encap, which is fine, right?
Yeah.
What you would have registered in the overlay system is the key would be the destination IP of that packet. The information about the overlay would be the tunnel dest and the encap type, VXLAN.
Okay. But go ahead.
And one of the things that spies you is, for example, with the NSH header, you've got 4 fixed context fields. Right now you're consuming one of them. It means you no longer have to consume, among other things, that context field in order to actually function. Actual application bits, members of the service function chain can now consume that slot for information they're passing as context about the chain.
But I still have to, because without that C1 having the network element destination, there's no other thing in the packet that's the key.
It's going to come out the other end destined for somewhere, right? It's going to have an IP address, a destination IP address at the other end.
No, that's the whole issue about egress classification with service function chains when using overlays, is that the inner packet could be within a namespace, like for the VM. So you might have 20 namespaces all with network 10, and the inner packet's network 10. And I have a follow-up question as well around this whole mapping and encap, because on your next slide.
Yep.
So I think one step that is not clear and maybe missing here is that at the end of SFC, you still have the packet, right? You have the IP address of the virtual machine in the packet.
Correct.
Right. And what you put in the overlay layer was IP of the virtual machine mapped as a key and mapped to IP of the server or the host or the network element that is end of the tunnel for that node, for that virtual machine.
So you need the IP address and the namespace, because 10.1.1.1.
Yes, and the namespace. So if you're talking, like multi-tenancy with overlapping addresses and so on, yes. So definitely VNI or whatever we have. I mean, the equivalent of that. So a tenant ID that determines the address space, the namespace. So within that namespace, so that is also something that you put when you're putting the mapping in the overlay, right? You say, in this namespace, I have this key, which is my virtual machine IP address.
Yep.
And it's mapped to this tunnel endpoint. And it may have VXLAN capability, or this is the transport that I want to use for encapsulation.
Okay,
For
so
instance.
the key would now be the namespace and the IP address.
Yes,
Okay.
yes, exactly. The
That's
key
fine.
is the namespace and the let's say IP address of the VM. Now this can be the MAC layer, the Ethernet. Yeah.
Yeah, so then the next question is, and thanks for that, that did clarify that. The next slide you got here, Ed, can we just maybe just quickly walk through
Of course.
an example I've got? And maybe there's an answer for this too, but it's not what I heard.
Sure.
Let's just treat these three gray circles on the right as network elements. And
Sure.
the northmost one on the top left
This is where we come in.
we'll call just a standard classifier. It doesn't have to be GBP, it's just a classifier. And the one on the bottom is also a classifier. And the one,
this is not an SFC picture. This is an overlay picture. Yeah.
we've been talking about this.
Sure.
So all I've heard is the keys and destinations and tunnel endcaps. We've already clarified one thing because you never mentioned namespaces. Now it's
Apologies.
clarified. There's another thing that needs to be clarified. So, and this is the way I can explain it best. I'm sorry. So the one on the top left is a classifier. The one on the bottom left is a classifier. Normally, they would use a VXLAN encapsulation in between them. So far what I've heard is my key would be namespace, inner IP address, which is great, that's unique. And from that I can work out the network element's IP address and what would be my tunnel destination and the encap, in this case VXLAN, right? That's great. Let's just say that that works for ICMP in my case. So ICMP traffic, I want to use a direct VXLAN tunnel. But for port 80, I want to redirect it to the node on the right, which in entirety is a service function chain, and in which case I need to use VXLAN GPE encapsulation. So my key, which is namespace and IP address, you said maps to the network element destination, which points to the one south, not to the one on the right, and uses encapsulation VXLAN. So how do I differentiate then between using this as a key, whether I'm going to the right or going south, because the difference is ICMP and port 80.
So
Does that make
you're
sense?
saying
The
you may
question,
want
first of
to.
all?
So the question is, you may want to have different kinds of endcaps, let's say, per not just the destination IP address and the namespace, but also the port or the class of traffic or something like that, or the
And
flow ID of your IPv6 system.
Can I ask a clarifying question? So you were talking basically, let's say it's port 80 traffic and you want to put it on a particular service function chain, correct? Right, which means that you are actually putting an NSH header on it, right? And you can use that NSH header as a key. So that basically when you have something that comes in with the key of that NSH header, that gets picked up by the mapping that SFC put in to the service, the overlay service that basically says for this NSH header, this is the topology that you're dealing with. And so basically, once you put that NSH header on, that's the key that you're using to run through the system, not the IP header.
Okay, so now we're using multiple different key types depending on the context of the thing I'm doing.
You need to work out some appropriate hierarchy for that, but yes. Yeah, but I agree.
Okay.
So Keith,
And that would go also then, sorry, go ahead, Vina.
I think that there are two things. One is exactly what, so if we tag, if we do the classification once and then we're tagging the packet in terms of where and how it has to go with, let's say, the NSH header or the SPI, then that would be your key, your unique key for specifically the type of transport and destination and all the stuff that you want to use for that specific flow, let's say, or for some flows that have to go through that chain. The other thing is that we can, in general, there is a flexible way, and again, we're looking at generalizing this to a overlay service, not just a specific to what we use in Lisp. So there is a way to kind of define new ways of doing mappings or extend the key into multiple tuples, and then, or still have the key, but then within that key, we have different kinds of mappings. So we kind of extend the key within, we have a hierarchy of keys in a way. So you can say my virtual IP, my VM IP address within the namespace is my main key, and then within it, I have some port address, and based on the port address, I pick a different, let's say, transport, or a different destination even. So I think there are two ways to address that. For the specific case of SFC, I think the NSH is the way that we can easily go about that and store the SPI as your key, and based on that, you'll get the differentiation you want. But depending on various use cases and different scenarios, I think generalizing the key as well as the values that we store is definitely something that we need to look at.
Okay. So good answer, and that's satisfactory. But this gets back then to the question I asked in the previous session, which didn't really get addressed because maybe I wasn't clear in how I was asking it. So if I have, I'll give you a concrete example. Let's just say namespace A. We'll just assume that tenant namespace are all being given, and so now I'll just use inner IP addresses to make it very clear. So I want to get to 10.1.1.1, right? And it's been registered as having, it lives on this particular IP address network element with this encap VXLAN, let's just say VXLAN. Because someone else, 10 or 20.1.1.1 over somewhere on the far right has said that's how to get to 10. It lives on node A, right? Now, there's another VM on node A that wants to reference 10.1.1.1. And it looks up 10.1.1.1 and it says, you live on node A with encap VXLAN. Well, that won't work. You can't tunnel to yourself. Please, and so if the solution is that I now need to know the topology of where things are and maintain a mapping of local to remote based on where I'm requesting it from, I'm beginning to struggle to see the value that the mapper provides. If the mapper can do source-based or requester-based awareness in the response that it gives, then I see extreme value, because then I don't have to maintain that map. And the less state I have to maintain, the better. And I can generically just say everything is an overlay. Even local things are an overlay, and this is a wonderful thing.
So in Lithium, we do have support for source and destination two-tuple mappings. So based on the packet, based on your request, you can have your source as well as a key, and then within a destination, we can look at the different source mappings and decide what we want to return to your source specifically, and you can modify that.
So I'll cede my time and reserve the right to follow up, because I would like to follow up more on that and how we can make it more compact than that. Potentially.
Absolutely.
But
I mean,
you see the granularity that we're getting to almost the 5-tuple and multiple encap mapping already.
True. Yeah.
And it's centralized classification.
Flow-based mappings.
Like
Yeah, absolutely. Okay. I understand.
Anyone
that.
else?
And by no means the fact that we have source and two-tuple mappings doesn't mean that we cover all the cases. That's absolutely not what I'm saying. So it's just that we want to go in that direction, and it's not that that I think even that the LISP mapping service that we have in ODL is now as the way it is right now, the answer to this question in its entirety. So the point is that we're trying to go in the same in that direction, because that was kind of that is becoming the problem that we think we should solve.
No,
I
as
a community.
This is a very worthy thing to do, but as soon as I have to handle a corner case, then I have to maintain a lot of state. So I'm just trying to help get to the point where I don't have to do that. I really want to do this.
So you're giving, the way I look at what your questions are requirements for a general overlay system, overlay layer. And so I'm trying to keep note of that.
But we went from like 10,000 feet to like 100 feet in that question. But the basic, I think, requirement understanding was that the people that register into the system there needs to be some context that they're local, and that we need to avoid using the system to reach them. And I think that's supported by the architecture as it is today. In other words, in the existing control plane, again talking about the architecture, there's this concept of a site or a grouping of bits of information that share a common network element location, and those things, the resolution of that in the architecture is a local decision at that node. It doesn't even have to consult the mapping system, in the sense. Yes, I mean in the architecture. I'm not talking about
So,
the existing implementation.
really quick, guys, we're out of time. The session has hit time, and the key signing is going on. I don't want to discourage the conversation going on, but I'm going to unplug from things. So just wanted to make sure everyone knew where we were. But this sounds like it's been very, very productive. Thank you.